Material samples brought back from objects in space can shed light on billions of years of our solar system's history, including details about the origin of life here on Earth.
A piece of an asteroid is a piece of the earliest beginnings of the solar system. 4.6 billion years ago, when our solar system formed. Initially, there was just gas and dust swirling around, and that coalesced into planetesimals. And those things crashed into each other and got bigger, and some became planets, and those that did not remained as asteroids. And they're like little snapshots of Earth's beginnings.
But picking up rocks from the surface of an asteroid or planetary satellite isn't as easy as it sounds. It requires voyages of millions of miles to bodies that have never been seen up close. Probes need to land on surfaces with weak gravitational pulls, where the surface terrain is completely unknown, gather samples, and then make the long trip back. And while behemoths like NASA and SpaceX grab headlines, it's a relatively young space agency. The Japan Aerospace Exploration Agency, better known as JAXA, that is taking the giant leap necessary to bring the mysteries of space back down to Earth. If we want to find out about the origin of our solar system, or the origin of life itself, we need to study materials that were around 4.6 billion years ago when the solar system was born. Meteorites actually fit that bill, and luckily, the Earth is lousy with them. Meteorites make impacts with our planet all the time. There's just one problem.
そのためには、その46億年前、太陽系が生まれた頃の物質を、やはり手にする必要があると考えています。で、そのためにはですね、実は隕石ですね。地球に落ちてくる隕石もそういう小惑星の起源なので隕石を調べてもいいんですが、隕石は残念ながら地球に落ちてきてしまったので、地球の物質による汚染があるんですね。
JAXA itself was officially founded in 2003 when 3 different national space agencies were merged into one. Prior agencies in Japan had excelled in infrared and X-ray astronomy and the design and launch of communications satellites and rockets. JAXA continued those efforts as it began devoting money and research into sample return. With the need for relatively untouched materials from space clear, planning for the world's first sample return from an asteroid began in 1995. On May 9, 2003, the robotic spacecraft Hayabusa, meaning Falcon in English, launched, with its path set for the asteroid Itokawa, a near-Earth asteroid located between Mars and Earth. Using its 4 ion engines for the 1,200,000-mile-plus journey, Hayabusa made contact with Itokawa more than 2 years after its launch, in September of 2005.
That is a special challenge because asteroids are not as large as planets, and they don't have the gravity to allow you to just land. So you have to figure out how to land and stick there, and then have your instrument, your drill, or your collector operate in those conditions.
Not everything went according to plan. Weeks were spent trying and failing to launch Hayabusa's designated probe, and there was a fuel leak from its chemical engine. Part of the difficulty with the Hayabusa mission was with the size of Itokawa itself. Only 1,100 feet in diameter, its gravitational pull is weak, so Hayabusa had to maintain heliocentric orbit, meaning the craft would track the asteroid's path around the sun. In addition, the distance from Earth required Hayabusa to be fully autonomous, thanks to the communication delay.
到着する、前後ぐらいですかね、姿勢制御の装置が壊れたり、さらには2回目の着陸の後、これが大変だったんですが、燃料が漏れて制御ができなくなって、さらには通信が途絶えたと、そういう非常に大きなトラブルが続いちゃったんですね。
The probe was finally able to touch down and attempt a sample retrieval on Itokawa for 30 minutes.
ただ3年遅れたんですけどね、3年遅れて戻ってきたということなので、やはりはやぶさの場合はですね、何がポイントかと言いますと、世界で初めての小惑星サンプルリターンというミッションだったので、予期していなかったようなトラブルがいくつかあったと。でもそれをですね、いろんな知恵とか工夫を、使ってですね、
As Hayabusa returned, no one knew whether the sample collection had been a success or not. But upon its arrival to Earth in June of 2010, less than 1 milligram of dust from Itokawa was discovered in its collection module, a truly tiny specimen, but nevertheless the first successful asteroid sample return in history.
One of the conclusions was that the meteorite Itokawa that was studied was consistent with stony meteorites that we have found on the Earth, but we couldn't really conclude that until we could get an actual sample from the asteroid, bring it back and make a direct comparison.
これが一番大きな発見で、これは日本だけじゃなくて世界の惑星科学者が驚いた。
JAXA would expand on this flawed but successful mission with the launch of Hayabusa 2 to the asteroid Yugu in 2014. The second asteroid sample retrieval mission was notable not only for its more advanced machinery and distance of 9 million miles, but for its destination. Unlike Itokawa's inert collection of boulder-sized rocks, Yugu is carbonaceous, meaning it contains some of the solar system's most pristine, untouched materials: minerals, ice, and organic materials.
The carbonaceous ones are of great interest to us, especially in this recent Hayabusa 2 mission, because they contain remnant organic matter and also water that may have been the source of organic matter to evolve life and the source of water for the oceans on Earth.
After its approach to Yugu, Hayabusa 2 deployed a series of 3 small rovers that, due to the asteroid's low gravity, made a series of hops rather than roll on wheels to survey its surface. In order to retrieve a subsurface sample free from the weathering of space, the craft needed to fire a projectile into the surface of the asteroid, and in another first, created a man-made crater in Yugu. Hayabusa 2 was then able to descend and conduct subsurface sampling from the site of the blast. Unlike the first mission, the second was able to collect more than 5 grams of material from the surface of Yugu, now the largest asteroid sample ever recovered.
Originally, we expected to have the samples greater than 0.1 gram, but ended up with the 4.5 grams, which is more than 50 times of the grams. The next surprise was that there is the infrared microscope found water-bearing minerals.
The Hayabusa 2 mission sampling Ryugu has yet to yield information because the samples came back in 2020. They've been distributed to labs all over the world, and we'll soon get information from them on the origin of water, potentially from meteorites, as well as the nature of carbonaceous material.
JAXA's next sample return mission is set to be its most ambitious and illuminating yet, and it's to an area of the solar system that's particularly popular at the moment. The MMX, or Martian Moons Exploration Mission, is slated to visit 2 of Mars's moons, Phobos and Deimos, with a launch planned for 2024. MMX will visit and survey both moons with the hope of collecting a sample from Phobos in mid-2025 and a return to Earth in 2029. MMX seeks to find whether Phobos and Deimos are asteroids that became caught in Mars's orbit long ago, or if they were fragments that coalesced after a major impact with the red planet, as scientists more often suspect. There are also implications for the origins of life in our solar system.
衛星フォボスのサンプルを持って帰ってくることで、太陽系の中で水とか有機物のような、生命の元になるような物質がどのように運ばれてきたかということが明らかになって、で惑星系にどうやって生命が誕生したかということについての手がかりが得られると思っています。
MMX will be humanity's first opportunity at bringing back samples from other planetary systems, and JAXA hopes that the round-trip visit will reveal important information that can be used on future manned missions to the Martian sphere, including whether Phobos can be used as an orbital base. On MMX, part of the sampling will be done with the help of US-based Honeybee Robotics. Meet PlanetVac. The planetary vacuum sucks up regolith, another name for the dirt lying on top of the bedrock of space bodies, and collects it to either be analyzed by onboard tools or stored away for return to Earth. The planet vac takes the place of a leg on a lander and uses compressed gas that's usually already on board the craft to pressurize fuel tanks. MMX is still currently in the development stage, and JAXA says the cost will be around $419 million. If all goes according to plan, JAXA can further cement its track record as the world's premier experts at sample return. JAXA's sample return missions will, over the coming decades, help prepare other space agencies for manned missions to various types of environments in space, and as research continues on the samples already brought back, help to solve some of the mysteries that still exist about the formation of life on Earth.
この段階で取り込ませてもらっているということをとても誇りに思って、で、楽しんでミッションの開発を進めています。ぜひ成功させて2020年代のうちに人類初の火星圏からのサンプルリターンを実現したいと思っています。
The world over, smaller space agencies have found crucial niches that don't require the massive funding of NASA, Blue Origin, or SpaceX. In this way, JAXA is more than holding their own with our world's space heavyweights.